We will be looking at properties of functions from a graphical point of view. This should be a review from college algebra or a previous math class, but it's always good to review. So looking at a graph, we're going to try to determine the intervals of where it is increasing or decreasing. Now that's the part of the domain, remember that's the x values, where the y values are increasing or decreasing. Then we're going to determine the local maxima, which is the plural for maximum, which are the high peaks, that makes sense, and the local minima, which is the plural for minimum, for the low points. So let's just kind of go through and let's take some colors and say, well, where are they increasing? Well, increasing just means going from left to right. If you were walking along or you had a little car and riding along this graph, where would you be going uphill? Well, here, here, and here. Those would be all the places you would be increasing. But where would you be decreasing? Well, going down here, down here, down here. Well, what about those peaks and valleys? Well, the peaks would be this point, this point, and this point, and this point. So those would be some maximas, whereas of course the low points would be here, and here, and here, and those would be minimas. Pretty easy, again going left to right, increasing or decreasing. Let's just go through these questions. Determine the domain of a graph. Well, remember we want to go from left to right, and these are our x values. So how far left does it go? From negative 11. And how far right does it go? Goes all the way to 9. It's very continuous. There's no holes, so everything from negative 11 to positive 9 would be the domain. Now the range, this is where our brain just confuses us. The range, you want to look from down to up, where our brain really want to goes up to down, which means we want to go from low to high. Right, so what is the lowest point on the graph in terms of the y values? Remember the range is the y, and what's the highest point? Well, this would be from negative 4 to what, 2, 4, 6, 8, up to 10. And again, there's no jumps or holes, so our range would go from negative 4 to positive 10, all inclusive. Now, find the intervals where the function is increasing and where it is decreasing. Well, remember our increasing were the parts in yellow. Well, how do I write that? Okay, so increasing. We want to start here from negative 8 to negative 2. And we use open parentheses because at those endpoints, it's neither. That's where you get those maximums or minimums. Right, here we go from 0 to 2. And we have one more from 5 to 9. And these are our union symbols. So remember, that's where the x values. So the domain or the x values where the y values are increasing or decreasing. Right, now let's look at the decreasing part. And remember, those were the parts that I shaded in light blue. Right, so decreasing would go from negative 11 to negative 8, from here to here. Then we'd skip from negative 2 to 0. And then we go from 2 to 5. So really, if we put both of those together, we would get our whole domain except for all where the peaks and valleys are. And of course, that's the next question. Find any local minima and maxima. Right, so let's just label the points on the graph. The maximum would be at negative 11, and the value would be 4. Then we would have another maximum at negative 2, 6. That's this one. And way up there, we have one at 2, 10, and this last one would be at 9. It looks like a y value of 8. Those would be the maximas. Let's look at the minimums. All right, we have this point, which is at -8, -4. We're going to call that 0, 0. And did we have another one? Yes, we did. We had it 5, 0. Did I get them all? There's 1, 2, 3. Those were all the minimums. Step 5, finding the intercepts. What do the intercepts mean? It's where the graph crosses the x-axis and the y-axis. Well, we have quite a few. I wanted to clean my graph up so we could see these. Where are all the intercepts? Well, it crosses the x-axis here, 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 but it also crosses the y-axis also there. So we would include the x and the y-axis. So where would all the intercepts be? At -10, at -5, at the origin, and at +5, and of course the origin also includes the y-intercept. Now what about this? Determine f of -8. That means when x is -8, what is y? So we got on the graph, x is -8. What's our y value? -4. So -8, -4. What does that mean? Solve f of x equals to 10. Well, that's just the opposite of number 6. It says when y is 10, what is x? All right, so y is 10, I think, only at that one point. What is the x value? 2. And then my last one is, how many solutions are there for f of x equals to 6? Meaning, are there more than one place where y is equal to 6? Well, let's look. 2, 4, 6. So if I extend this, this is everywhere the graph hits 6. I think we could count 1, 2, 3, 4 places. So how many solutions? I didn't ask what the solutions are. There are 4. If we wanted to find them out, they would be at about -2, looks +1, close to 3, and right at 8. So there would be 4 solutions. So again, just to review about that domain and range and intervals of increasing and decreasing. Now let's look at some symmetry. You have an even function if it's symmetric about the y-axis, and you have an odd function if it's symmetric about the origin. This would be an even function because here's our y-axis. It acts as a mirror, so this side is the same as that side. This would be an odd function because here's the origin. So try to imagine if you could fold your paper where you could fold it vertically and then horizontally. This would match up with that. When you were in trig class, did you have even and odd functions? Yes, you did. Your cosine function was an even function. In fact, I think that's what this part of the function is. And your odd was the sine wave. So you've seen these terms before. We're just again reviewing. So let's just look at these 3 problems. Find the intercepts, the domain and range, the intervals of increasing, decreasing. Oh, constant. That's different. Whether they're even, odd, or neither. All right, so part A, the intercepts. Where does it cross the x-axis and y-axis? Well, here are our intercepts at -1, 0, 1, 0, and 0, 2. That's pretty easy. Part B, the domain. Remember, those are the x values. So how far left and how far right does it go? From negative 3 to positive 3. From negative 3 to positive 3. The range, remember that's the low to the high, the y values. So from 0 to 3. Again, x values for domain, y values for range. Then, intervals of increasing, decreasing, and constant. So, increasing part. Where are we going uphill? Here and here. And we're going downhill everywhere else. So, increasing, again, the x values from negative 1 to 0. And the next x values from 1 to 3. Would be decreasing everywhere else. So we would have from negative 3 to negative 1 and 0 to 1. Constant. What does constant mean? Constant means you would have a flat part of the graph. That means y doesn't change, and we don't have that on this particular graph. And is it even, odd, or neither? Well, even means it's symmetric with respect to the x-axis. And yes, the right side looks like the left side, so part D, this would be an even function. All right, let's look at the second part, second graph here. All right, so we want to find the intercepts. 1, 2, 3. So we have two x-intercepts. That should be negative pi over 2, 0, positive pi over 2, comma 0, and 0, 1. Of course, this looks like my cosine graph. Part B, what is the domain? Well, this particular part of it, it goes from negative pi to positive pi. And what is the range? Well, it goes from a low of negative 1 and a high of positive 1. Where is it increasing, decreasing, or constant? So increasing here, decreasing other places, increasing from negative pi to 0, and decreasing from 0 to pi. And of course, this is also an even function. It's reflected in that x-axis. The right side looks just like the left side. Our last graph, what are the intercepts? We have 1, 2, 3, so negative 2.3 comma 0. We have 0, 1, and 3, 0. The domain, the x values go from negative 3 to 3, and the range, remember the y values, the low to the high, again those y values from negative 2 to 2. Then we want increasing, decreasing, or constant. Well, it's increasing here, and we have a constant part there. All right, so let's throw that in. So part C, it's increasing from, again, x values, from negative 3 to negative 2, here to here, and from 0 to 2. It's constant, this part, which would be from negative 2 to 0. And it is decreasing just here from 2 to 3. So just looking at a graph, answering some questions.